From the Thinkubator at the Tech Valley Center of Gravity, this is STEAM Powered Saturday, a free monthly event where children ages 4 to 12 and their families are invited to visit us for a fun, creative, hands-on project. These mind-expanding projects help children discover creative play through science, technology, engineering, the arts, and mathematics.
Hello engineers! Today we are going to be designing and making mini catapults. We will learn about the history of them, and we'll think about projectiles that you shoot with them, and we'll even be designing some walls to shoot them at. So let's learn a little bit about the history of catapults. So when people started living in cities, they built walls to protect themselves in the cities from people who wanted to take their things. The problem with that was that those people who wanted to take their things needed to get into those cities. So they built catapults to tear down the walls of those cities. This all started happening around the 4th century BC when the Greeks invented the first catapults. Now they were redesigned many times after that. The Mongolians used them when they invaded Europe. The Chinese used them when they were fighting different wars. And so did knights of the Middle Ages. All of these people were using catapults of different designs. They used trebuchets, they used these giant crossbow catapults called ballistas, and they used the classic design of a catapult. Leonardo da Vinci also designed a catapult, and here is a model of that. Let's talk about the science of a catapult. A catapult uses potential energy, and then it releases that energy in kinetic form. So I can model that by just taking this block and lifting it. As I lift this block higher off the ground, I am putting more work into it, which adds the potential energy. So the higher up I go with this block, the more potential energy it has. And then when I drop it, that releases that energy into kinetic energy. A catapult works the same way. As I pull back on this arm, you'll see that there's a little bar right here that's kind of like a spring. I'm actually increasing the amount of potential energy that can be released. That's why it's called potential. So the greater or the further back I pull this bar, the greater tension there is on this little lever here. And when I release the catapult arm, it releases that potential energy into kinetic energy. So if I was invading some village with a wall, probably not a village, a castle with a big wall, I would need to have a lot of energy thrown at that wall to break it down. Okay, and that would take big materials like rocks, and that would take a very powerful catapult. Of course, we're going to be making mini catapults and breaking down mini walls today. So let's talk about the parts of a catapult. The catapult has to be on a base. That gives it support to build everything. You also have a fulcrum. The fulcrum of your catapult is what the bar, the arm, tilts on. You have a spring which holds all the energy. Here's the spring here of your catapult. Here's the spring for the Da Vinci catapult. You have the arm, or the bar, and you also have a bucket. It holds the projectile in it. Oh, and you also have a projectile that goes inside your bucket to shoot it. And those are the parts of a catapult. Today I'm going to show you how to make 3 different catapults. So we're going to make one out of just a plastic cup, and that's it. For this one, all you need is a plastic cup or a plastic bottle and scissors. We're going to make one out of popsicle sticks, rubber bands, and a plastic spoon. And we're going to make a more complicated one out of an alligator clip. I think it's just like a little black clip you get from, to put papers together, popsicle sticks, hot glue, and a cap. Some safety tips when building your catapults. If you're using scissors and you're cutting through something other than paper, have an adult help you with that. Scissors are only built to cut paper. If you cut anything else with them, it's dangerous and they can break, or you can cut yourself pretty badly with them. If you're working with hot glue, work with an adult. Hot glue guns get very hot and they can burn your skin. Also, when you're shooting your projectiles, do not shoot them at people, pets, or anything alive or anything that can break. It's a projectile that flies through the air and it can hurt things. So make sure that you only shoot at things that you build, like a wall, and experiment gently first with your catapult before you do a full-on catapult test. Our first catapult is made out of a plastic cup, just using scissors. You'll need a projectile of some kind. This is a marshmallow, and a plastic bottle or a cup, and that's it. So this one, you pull back your arm, and the fulcrum is actually created by the tension in the plastic. You place your projectile in your bucket, and then you shoot. So I'm going to draw lines on this cup to show you where to cut to make a catapult cup. First, you draw a line, or cut a line here and here. That creates your arm of your catapult. Then you're going to cut a line right about here, and then right about here, and right about here, and right about here, and maybe another one right here, and right here. That's going to make your bucket, and that's really all you need for this catapult. I tried a few different designs where I cut a handle out of it. You can see that right here, but it didn't quite work. I think I would need to tape them together to make the handle work, and honestly, when I pull it back, it holds the catapult bucket too far up, so I didn't use it. I just held this part with my hand, which worked better. But you're going to have to experiment with what works best for you. So now that I've drawn those lines, I'm going to cut right along here. This is where you might need help from a parent because scissors can be very sharp, and so can the plastic of a cup. You want your parent, you can draw the lines, but your parent or an adult should cut this for you. So there's the arm. Now, when you cut your bucket, you have to think about where the bucket's going to shoot. It's going to come from this top, so I have to cut the lines and fold them up this direction. So it doesn't have to be exactly on lines like this. These are just kind of made up here. You can see it's a little bit challenging to get the cuts in there. The hardest part to cut is through the lip of the cup. That's where you have to be careful. Look how close my fingers are right there. That's why this is, needs to have an adult help you. So you can easily cut your finger with these scissors. And you have to push really hard to cut through there. There we go. And that's where you could really hurt yourself. All right. So now that we've cut all those lines in there, we need to form our bucket. So I'm going to bend up this side. And honestly, that's probably going to do it right there for a bucket. I could put some projectiles in there and shoot them. But the more protection I give the bucket, the better it is at holding on to the projectile I throw in there. So let's see if that works, the one I just made here. Here's my marshmallow shooter. The next catapult we're going to make is the spoon catapult. So you might notice there's a big difference between these two catapults here. This catapult comes up almost at a 90-degree angle from the ground. So does the Da Vinci catapult. That's really cool because when I shoot this catapult, well, this one goes past the spot. If I actually had a block right here, it would make the catapult shoot straight this way. The Da Vinci catapult actually has a little piece of wood inside of it that blocks the arm right when the arm gets to 90 degrees, which means it shoots it straight at a wall, which is how people who originally made catapults like this wanted it to work because they wanted to knock down a wall. So if you see this catapult, it doesn't go at a 90 degree. It kind of just shoots like this, and you'll see that when I put a marshmallow in here, it shoots it straight up in the air, which is kind of cool, but not that useful as a catapult. I'm going to try to make one a little bit better that shoots it out a little bit further. And you can kind of play a fun game with this one. Maybe instead of knocking down the wall, you could try to shoot the catapult projectile into some cups. You could even put numbers on the cups, like 100, 50, 10, and make it a game, like a shooting game of shooting the cup inside it, like a basketball game. But let's try to make that one now. So you'll need something that you can stack up and put together for a fulcrum, and that will also be the base. I'm going to use popsicle sticks and rubber bands. The first thing to know when making a spoon catapult is how to attach rubber bands to these sticks to make them connected. So you put the sticks inside the rubber band and you twist and you wrap around and you twist and you wrap around and you twist and you wrap around and you twist and wrap, twist and wrap, twist and wrap. And you can make the rubber band hang on to here. Much like if you have long hair, if you ever put a hair tie in your hair, it's a lot like that. So that's how you can put the base together for this catapult. So you can make a simple catapult just by putting a fulcrum anywhere over here. So I could actually put something in here, and even this right here, if I could find a way to make this structure stay like this, I have a catapult. But you can see it's a little flimsy. It kind of works. But the problem is if I put a projectile in there, it falls off. So you need a bucket. So to attach a bucket, we can attach a spoon to this catapult. If I slide the spoon handle inside one of those rubber bands, I have a catapult. Let's see how it works. So I'm actually taking the wooden piece here to push back. That works pretty good. So you probably couldn't see where that landed, but the marshmallow went about a foot away and about 3 feet high into the air. So that would be really good for shooting baskets. So now we're going to make the last catapult, which I think is one of my favorite ones, and it's the closest one to the Da Vinci catapult. The materials you'll need to build this catapult are as follows: a base piece of cardboard, a popsicle stick that you'll glue to the base, a binder clip that we're going to glue on top of that base popsicle stick. We're going to add a stopper, which will help us aim our catapult. And that's just made from a slip of cardboard that's glued into a triangle. You'll need 2 popsicle sticks that are broken off at a straight line instead of the curve that will act as the arm. We'll need a handle and a little strip of cardboard that we're going to make into a circle, glue it to our arms as our bucket. Let's build. I'm going to glue the base popsicle stick to the cardboard with some space on this side of the cardboard to attach my stopper plate later. Next, I'm going to glue on the binder clip. I'm going to put glue on top of the popsicle stick, place the binder clip on top of that, and then put a little glue over the end of the binder clip. That'll create a better bond to keep that clip from jumping off of that base. So now we have our base and our fulcrum. Next, we need to add our arm, our bucket, and a handle to pull the arm back. So the arm is built with 2 popsicle sticks that are on either side of this piece of metal on the binder clip. We're going to glue those together like this. And put some glue here, a little right up here, and then I'm going to put glue right here on my arm and attach them. Again, as I've said before, it's a very good idea to do this with a parent so you don't burn yourself with the hot glue. Let that dry. Going to do a little support glue on the sides to make sure it really sticks good here. I don't want my arm to fly off. No one ever wants an arm flying off. Okay. Now I have 3 more pieces to add to complete my catapult. The stopper, the handle, and the bucket. Let's attach our bucket and the ring. I'm going to glue it together. I'm going to hold it without touching the glue. There we go. Going to put glue on my bucket and put it right up here. And now I'm going to pull and glue my trigger on here. Not my trigger, my handle. Just a little glue will do. And this time we're going to use a stopper plate, which will help us aim our catapult so that it'll stop and shoot the projectile forward instead of straight up or down. To do that, I take a piece of cardboard and I make it into a triangle, and you can actually adjust the way that, or where you want your catapult arm to stop by moving this triangle and making a different size triangle. So I'm just going to put a line of glue right there and attach my triangle and see if I want this stuff out right there. There we go. That'll be my stopper. And think about where I want to stop. Yeah, that's good right there. Now I'm going to glue the stopper on to the base. And we are ready to test. Perfect. Thank you for joining us at Steam Powered Saturday here at the Center of Gravity in Troy. Look around your house for some materials to build a catapult. Build it, redesign it, build it again, redesign and build. Experiment with some projectiles and knock down some walls, and share what you build with us. See you next time.
We want to thank the Albany Society of Engineers Foundation for their generous ongoing support of Steam Powered Saturday. Our special virtual editions are brought to you through additional support from GE Healthcare in Troy, New York, and Agora Media. We'll see you next month on Steam Powered Saturday.